of AI. This relates to an NSF grant and a research that we're doing in the realm of product design, where we're trying to understand the implications and the potentialities of using AI as part of the design process along the different stages. And Ryan is a PhD that is in charge in a way to conceptualize a framework for design knowledge being part of the process of designing the algorithm itself. So without further ado, Ryan, the stage is yours. And this is a conversation trying to be interactive as it was the first event is morning. So please feel free to stop him, interact.
Stop me or anything like that. I'm gonna be remaining at the high level, presenting a theory that we hopefully find practical implications within our understanding of AI as designers. So I'm asking the question, well, what does it mean to design an AI? So just a quick overview of what is generally, like, this is Britannica, what they say of an AI, and it's chiefly looking into the components of learning, reasoning, problem solving, perception, or language. This combination is traditionally found within this. So you have artificial intelligence at the largest level, and at the lowest, deep learning, like your neural networks, GPT, and then different types of intelligent operations like natural language processing, computer vision, robotics, that falls under the net of artificial intelligence. So just a couple examples of that big net of artificial intelligence, and autonomous driving is one. So learning to perceive your environment, not to hit anybody, that's always important. And being able to train that, so you see different types of evaluations, car 0.94 in snow. So that's the confidence rating of a vehicle, and the car beside it. You can see how it's visualizing. Some other ones that people are probably quite familiar with is DALL-E, using language and image generation to combine and produce images that are supposedly photorealistic. And then some others that you might not be so aware of is in your phone camera, your zoom and focus is artificial intelligence is there. Different types of neural networks, especially deep learning and machine learning, to focus and learn the environment through computer vision. And then underneath the hood, we have at that lowest level that I presented, AlexNet or VGG, which were different types of convolutional neural networks, and GPT, which is what's kind of powering our ChatGPT. And what I have to say about all of these different types of models is that they involve a different creation of these models, involve planning, selecting the training data, data annotation, selection of algorithms, parameters, hyperparameters, tuning, model training, etc. And all of these decisions are currently done quite ambiguously by engineers and computer scientists. There's obviously some rigor that goes into this, but there's a level, like, for example, producing realistic images, it's a probabilistic choice, and comparing between how a model performs on its test data to its training set. But I would argue that this has serious impact on the models that are produced and their effects once they're in the real world, once we have these limitations and these ambiguous design choices. And so how have designers thought about these models once they've existed, once they're existing in the world? Well, how they affect design processes. We're thinking about this, as I've used in a recent paper, a posteriori, so after the fact. It's existing, how is it affecting us now that it exists? But as the dictum goes, we shape the artifacts that shape us. So I think that designers and design has to seriously consider the effects that design has on artificial intelligence. And those design choices, like the selection of data, the parameters that go into the creation of artificial intelligence, and how this actually shapes the models that are going to exist and going to affect us. So my argument is that the creation of artificial intelligence models is design. And as Richard Buchanan wrote in his Design as Rhetoric, that the primary obstacle to such understanding is the belief that technology is essentially a part of science, following all the same necessities of nature and scientific reasoning. This is true, technology cannot be a part of this rhetoric, except as a preformed message to be decorated, has to be transmitted. However, if technology is in some fundamental sense concerned with the probable rather than the necessary, with the contingencies of practical use and action, rather than certainties of scientific principle, then it becomes an art of deliberation about the issues of practical action, and its scientific aspect, in a sense, only incidental. So I believe that design is, in fact, at the root of the creation of artificial intelligence. And so today, I want to talk about what that actually looks like, and what is design doing at the very beginning of what design knowledge and the shaping of artificial intelligence. So I'm going to offer just a concise definition of design. So as we saw, science deals with how things are, whilst design deals with how things ought to be. I'm going to keep it at that. You could argue that it deals with how things should be or could be, ought to be. You leave it a bit less, I guess. So the type of problem that an AI is, that's complex and ill-defined. What I mean by that is that ill-defined problem is one that allows something to emerge that could not have been predicted. This is something that are predicted with certainty, but that the new thing of value has some of interest. So, we think about the creation of these large language models and the way that we talk to them. There's some value and some interest, but we don't really know. These are ill-defined problems because we didn't know that that was going to be the outcome. It's just the product of its training and that combination of choices for design actions, deliberation that manifested that model. And AI is also complex because there is no simple organization manual to create it, right? There's nothing that tells us the combination, but rather certain types of consistencies, like to learn, it needs to have back propagation. I'll get into that, but this is the way that it updates itself and learn what it's doing. And so design knowing is how we find possible elucidations to the complex, ill-defined problems of AI. So design deliberation is about how an AI ought to be. Design is at the beginning. So I'm going to go through 3 examples of design's existence and design knowledge, particularly in the creation of AI. And I'm going to move up through that kind of Adidas symbol that we saw, right? So I'm going to start at the lowest level of deep learning and the types of how design is actually the creation of neural networks in this case. So starting with the type of ill-defined problem, complex problem, how do we build better classification networks? So we had begun what had traditionally been done since the late 20th century and then the early 21st century was we had these shallow networks known as feed-forward neural networks that would take input layers and update its weights. Here's my mouse. Update this hidden layer. These are neurons, and then make some type of output. And that was a classification. So it'd be able to classify the image that it was looking for. What happened in 2012 with AlexNet is there was further layers. And within each one of these layers, there's specific operations that took place. Or sorry, this is VGG. Let's start with AlexNet that decided how to break down the image rather than just learning random points in the image, learn how to break down the image to do the same type of classification. So as you see here, AlexNet was able to, in 2012, with the first deep learning model, able to go and classify images on an image net, which is a test set, of just images collected from the internet, pre-labeled, and 1,000 class objects, and it had an error rate of 16.4%. And then in 2014, we got BGG, which was 19 layers. This reduced it by less than half, and so on until these models were performing better than humans in the test. This was happening in 2017 that we got these better performing classification models. And of course, having to classify with 1,000 objects, 100,000 images, it's quite demanding and exhausting on humans. So there's a lot of these different resources considered, but it's the matter that we had certain architectures that were performing to an extent that we hadn't really expected. And we don't know why they were performing. It was just a combination of all of these different types of layers to create a classification of either a car, a truck, a van, bicycle. So what was happening is you had a network going through the image, weaving, as you see here, creating data points. It would go down and by giving it a weight of what it saw, decide what it was classifying. This was happening. So why is this design, right? I think that was the main question. Well, what CNN ought to be to perform best on image nets? Going back to our first question, what are they? And so learning different types of CNN layers, it involves design decisions of hyperparameters. So these are complex, challenging engineering problems, let's say. But we wanted to find all the different ways that we could break down an image to get to one output. And this happened a bit ambiguously, just different expensive testing, the different schools and institutions that could offer it. So it kind of closed off the accessibility of these models to be able to create better convolutional neural networks. So design, they say, is about making sense of the problem and finding a semblance to that solution. Okay, so what is the sense? Like, what is the criterion necessary to reduce the error? Okay, these are premises that have to go into the consideration of a CNN in this case. What is a combination of these different hyperparameters to reduce error rate? This is the form in which these premises are presented. Okay? And so as designers, we are deciding how a CNN ought to be to perform best on ImageNet. These are complex design deliberations, but the actions made here scale up and have larger consequences in the models that we see. So now, currently, the one that we're faced with, I think most presently, is GPT, right? So the ill-defined complex problem of GPT is, how do we create a GPT architecture to learn language context? The deliberation of design, what GPT ought to be to pay attention, what GPT ought to pay attention to text data to learn language context. And so by going through the design, we ask, what is the criterion that GPT needs to pay attention to in 570 gigabytes of text data? What is the combination of these parameters GPT is needed to pay attention to? And so all of these things, whether we want to pay attention to certain aspects and sentiment and issues, right? You make these decisions early on. A model is going to be contextualized early on in what it's paying attention to. And it's going to scale up until if you make an ambiguous decision, let's say, that we only want to look at certain features of the face, it's going to always look at these faces in a certain way, and it might start to segregate or have other repercussions. And so I'm just arguing that at the early stages, design decisions are necessary and deliberations are necessary to affect models. And we can go up when you have these models combined within a larger context. So what if we add deep learning in some type of function? So currently on a project that I'm part of, the NSF, we're looking at how do we annotate online user reviews for meaningful insights? So we ask ourselves what AI ought to be to elicit user needs from online user reviews. Okay? And go through this. We got to make sense of the problem to understand what user needs look like in user reviews. What are the different levels that they appear, explicitly, implicitly, latent? What is the latent levels of these needs? And we break them once we understand the sense. We can ask ourselves, well, what is the semblance or the form that the sense establishes? We must consider the current and future possibilities of deep learning and natural language processing, such as sentiment analysis, pre-trained models, and annotation techniques. So as a group, we went through, we did this process of establishing the sense and the semblance of this problem. We came up with a categorical ontology of shoes and users commenting on shoes. This is this classification. We did this through a grounded theory approach, so building it up through iterative, looking at a bunch of language, having people code, combining our codes, continuously going until we came up with this three-piece where we have performance or your function, and some subcategories, appearance, as we know, form, design, and context of use, or the information exists. So we went through this, but there was also the types of data collection that you go through when you establish this ontology. And so we had designers last summer go through and work and collect data by annotating language, as you see here. So using an annotation method that we derived as designers with NLP, with the natural language processing experts, deep learning experts, we developed an annotation methodology that was able to extract the implicit levels of language and user opinions. So we got very, very valuable insights from in which we are looking at. And then to do this algorithmically or with a deep learning model, we constructed a unified T5 model to be able to look at user language and extract users' needs or annotate user language for inputs and for insight that can be used. And so going through that process in which we've seen of identifying the ill-defined problem, asking what ought to be, and then establishing between the sense and semblance, we arrive at an AI. And we know what went into contextualizing this. It's very important. At the largest level, at the systems level now, that model we just saw is fitting within a larger system. So we ask what AI ought to be to elicit latent user needs from online user reviews. We only got to like the implicit level. Now we ask, well, first, what is a latent need? And so in our context, a need for the user is derived from the product's inability to achieve the task put forth by a demand, goal, or problem. A latent user need is one where the user does not know that this even exists. It could be asked of a product that has the potential to arise for that user. And so we have to make sense of this. So in similar fashion, we ask, as we asked in the two previous cases, what is the criterion for truth or falsity, and what is needed to satisfy the latent problem? And then what must then find semblance that satisfies these premises. And so in a recent publication, we showed that design knowledge is a necessary condition to organizing and identifying the certain types of needs that are within regional language, and especially how to map the identification of these needs. And so this was just through, we just realized that past methods to do this were deductive and conducive and unidimensional, so it pigeonholed the user, whereas design knowledge being an adaptive process logically was able to actually expand the search space and allow for the multi-dimensional aspects of the user. So this informed the system map that went into our larger, that's going into our artificial intelligence. And what's interesting about this system map that design knowledge informs is that, and this was actually before designers were there, but that it's replicated by many different design processes that I'm sure we're quite familiar with. So we actually see these different types of user-centered design processes replicated in just the system map of an AI. And so we see the existence of design even at this largest system levels for an AI. So what did we see in an artificial intelligence? We saw design exist in the kind of conditions put forth in GPT and CNNs. We saw it in the same way by establishing that it was an ill-defined complex problem, the sense of semblance to identify the ways to organize these models, create an annotation model that incorporated deep learning and natural language processing. And then we see design knowledge at the very largest size of an entire artificial intelligence. So what's the conclusion to this, and why is this important for designers, right? Well, that we see that design is foundational at all three of these levels, at least establishing semblance and understanding the complex nature of the artificial intelligence that we're working with. It shows that it's not a black box, that it's constructed from the ground up, that there's certain decisions that go into the making of these systems that implicate the algorithms used. It's not an ambiguous manifestation, but involves design knowledge to deliberate a model of construction. So this is a type of the algorithm, the model, the system is a type of material that needs to be addressed by designers, because we shape the artifacts that shape us, essentially. Right? And so designers need to be involved at these early stages rather than assuming that they exist. So by understanding the intricacies of design knowledge for the formation of AI, we can begin to assess the impact that certain actions have in shaping these models. What is the effect of the data used? The people that must be engaged with the creation of these systems for them to exist afterwards, and the future shapes and impacts of these systems on the world at large. By understanding the early process that goes into this, we're able to track and understand the impacts. Why does design knowledge at the early stages? Rob and I were talking before, why is it that design knowledge necessarily makes a more impactful model than the designer going to ChatGPT, to ask it its questions? Why can't it do what a designer wants, or how will it affect negatively our assumption that these things just happen? I don't think it just happens. I wanted to show that designers need to be present. Thank you.
Any reaction to that?
Can I ask a question?
Yeah.
So in your presentation, you seem to suggest that there is one perception of the problem. Maybe I got it wrong. But what about the chances of looking at the problem from multiple perspectives before engaging the design process and before taking had you consider the ability to take the same problem from different perspectives?
Yes, I think that multiple perspectives go into it. I presented each segment as dealing with the one problem, but when you get to different scales or different functionalities, you have to ask the problem angles. So the like these large language models, I think, because they're so present, you have to ask, well, how is it being contextualized? And then I can understand that problem without that lens. But also from the other side, how do we break the language apart? And then this is a different perspective. And so we need multiple perspectives, or again, whose language are we using, and the type of language we're using, who's involved. And so by bringing all these questions together and the design capabilities of, establishing a criterion of what that means and finding a way that that's actually represented within a model, I think we're at least able to visualize the outcomes more clearly.
You think it's fair to say that, as you're putting it here, the bulk of the designer's work is in setting up the learning environment, so to speak? So the P and GPT is like pre-trained, right? You're kind of setting up what's the input, what's the kind of prerogative of the learner, and then from there, there's a lot of activity that's kind of not entirely controlled. Look at it that way, like setting up the learning environment, and from beyond that, you're less involved, or how does the involvement go over time?
I think that's really important. So as traditionally put in product design, making artifacts, you set up the environment to the form in which it's just going to exist for somebody afterwards. The same way you're doing this for an artificial intelligence, you're creating a context in a way in which it's going to be shaped, and you're already kind of morphing it. But then the idea of intelligence is that it can learn on its own, and that it's going to create. But what happens if it like AI in the wild or runs loosely? There's been certain recent articles, design studies, for example, the cautions of AI in the wild, and it was negatively affecting design teams and design teams because it was just an SVM model that was just trained and then expected to work in the way that the designer would, and it was actually impacting their production. So I would think that, well, if we actually show the environment shape, then it will be contextualized in a way that's meaningful for designers or, for a user and a large audience.
So, as per you, in this context, what kind of a role does a designer have? Is it like a front-end role or a back-end role?
I think that it's in the org. Where designers are not computer scientists.
Yeah.
I think that designers are there and organizing and modeling the possibilities for an artificial intelligence. So rather than it sporadically happening, or as I said earlier, just ambiguous choices as what would be next, kind of what's done is the professional computer science engineer might go for the lowest hanging fruit. So they choose the next kind of possible AI deep learning model to use or something like that. Design will enable by giving models and ways of kind of systematizing and seeing the larger impact that the model will have and what it's and then. So it would be at the back end, it would be in the early stages.
The reason that I thought about this was because I think it was shown on this screen also that I think there was a case study of a Facebook user, like after the end of the year when Facebook had this algorithm to show the best memories of that user. The photo that was shown was the photo of, I think, death and something like death related to her father. And the algorithm could not understand the sentimental side of it, but it chose that photo just because it had a lot of interactions.
Yeah.
So in that case, there was a conversation when they were saying that designers, although they are in the back end, they should come in the front end and help AI connect with the user.
Yeah, I also think that users should be involved at the beginning as well. So by understanding that design knowledge and this is impacting the way that a model is shaped, you can understand, well, as Laura put it earlier, there's a level of participatory design, co-design that needs to take place in models. This interaction is going to help it understand and what is that it's not always, I said the argument with realism for fiction representation. It's not always going to be what has the most likes, but these types of values that are established, I think, are a design challenge. Designers understand the values of designers.
Sorry to speak a bit louder because preparing that are not
I'll try to speak up a bit. I think that it's easy to say that AI is not a black box, but for a lot of people who have limited understanding of it, it's all AI is AI in the wild and is running loose, and this is a totally unknown system. And I appreciate this kind of framework to talk about the subjectivity of it and the design of it. And what kind of next steps do you think could be taken to kind of, hypothetically say, like, create a more, a more approachable, common shared language for what these systems incorporate, thinking almost like like seeing something is vegan on a menu, or seeing like rating system of like, this is potentially subjective, or this has some sort of, this is using some more advanced framework, or kind of making this more understandable to people that these things are designed and this isn't some, some black box.
Yeah. So I think there's two perspectives that I take on it, but I've taken them. That's so if we look at it, once the AI exists, there's people that are using it afterwards, and there's people that are impacting before. So what I think you're talking about is the people that are using it afterwards. How do they know what was done before to impact it? So there's certain types of ways of presenting it at the highest level in terms of like an application, that you would be able to know that the decisions that you make are where they're actually impacting the model, or changing a certain algorithm around, giving it a certain way to bias. What happens before, I think, is also important, where like in our current study we're conducting, we're having we're mapping designers' reasonings, we're finding latent user needs to think aloud, and then being able to inform the construction of this model. And what we hope to observe is that this will perform better than a generalized model. But if we know that it will perform better, then we know what exactly is going on at the base level to construct it, and then we'll be able to map that to those end users, for the people that use it after it exists, and be able to create a dialogue between before and after. Or better, once you're using it, the way that you inform it comes back to the new conception of that model. So I think there's a transparency, but transparency isn't necessarily, you're not able to get transparency in these models until it's recognized that each stage at the beginning is designed and they can map it. Because right now, black box, because it's just not mapped or modeled.
There's a question on that. If you want to read it,
Oh yeah.
answer perhaps.
Okay, I'll read it out loud. It seems that the difference in approach shown here versus AI engineering without engaging design is iterative, questioning without looking for an exact answer, which seems like what the AI is doing itself. So a meta level of questioning is achieved in opening and closing scope. Do you find that this convergence/divergence scope is well received by others in the space of creating, coding, engineering AI? I think that, like, I'm gonna be like pessimistic, but I think that what's happening is there's a couple of factors that go into the creation of these models. One is obviously like money. So when can it be made? What can it be made? There's a timeline and competition externally. So I think what's nice about so the models that are going to be made in like an academic setting, they're not going to outcompete the super large 25,000 parameter models of Google or with all this data. But what the opportunity, if I understand correctly, to co-design and have converging and diverging scopes is that you can focus on specific instructions or problems that might not be achieved by just the marketability of these other larger models that need to be made within like a institution or something like that. So I think that it's being more received, but I think it's only with our work and hopefully in the future that designers are actually engaged more within the beginning stages. I think it's now being understood that these ill-defined complex problems aren't going to be solved by just a random connection of deep learning models. It's rather a connection of kind of the early symbolic school of AI and this neural network school now to create synthesized models that have both. So I think that design is coming to the fore because it realizes that to solve those defined complex problems, design needs to be there. And that's what I'm arguing for.
So is there a lot of resistance among the computer scientists to this proposal that AI is designed?
I wouldn't say so, but I think that just computer scientists don't think about it because what they're concerned with is model performance and creating models. So I think it's just lack of interest maybe. But I like just because like it, you know, I think that it's like again the pessimism is that it's not super marketable tests that are theoretical questions. It's only now because what's happening is the cart's going before the horse in a lot of these models. It's what is easiest to make, like or what's the next thing to make, rather than what is the impact of the effect, or where could it go. So I think the theory or the design of these systems is catching up slowly. Not resistance, it's just that it's only this interdisciplinarity is only starting to emerge.
So, thank you for representation. Your experience working with engineering and science, can you give us a set of tips for us as designers collaborate in this collaboration?
Yeah.
What have you find are good practices that we get in this collaboration?
Well,
First, you had to take a course on machine learning. You did, right?
Yeah, I did that. So you have to learn how to speak the language of the other, and how to speak design language, and then find a common language. But then it was also a matter of, it's not clear here, but that's okay. We model it. You would create. I think we talked about this on Monday. But there's something that if you don't have verbal language to communicate, there's ways of representing visually or through like an artifact or through a model design that the concepts and the ideas can be transmitted. So I think that design's power and like the way that it's enabling artificial intelligence is being able to map and model these complex systems, being able to show that is what's necessary and what needs to be considered. And then as you kind of, let's say, level up in design, or you become more experienced, what to engage with externally, who to ask, the types of users that need to be involved in research methods. I can go into it's finding a language, being able to speak when it's not easy.
So just a question on problem statements and how we find them. As designers, how can we ensure that these problem statements that we create will be relevant in the future? Because they're ever changing. So we want to create something that lasts.
Yeah.
How do we ensure asking the right question?
Yeah, I think that goes to the effects of design. I was reading recently papers about anticipation. Design is very strong in anticipating futures and future possibilities. You have to look at just the way I see this. I don't think that there's a clear way, but this is who gets to ask the questions and how are these questions asked. Get this, see who our stakeholders is one, but also the people that you're affecting and the possibilities of their benefit in the future for those people that you're affecting. So somebody's asked, how can we connect the language prompts to unique image generation? The OpenAI people asked that question, right? And their stakeholders, are like Peter Thiel and like Elon Musk or whatever. But then their users, the people that they're affecting, is this general population, and then they think of stakeholders as like marketability. And so you think that for them, it might be that if we can have an AI that's marketable, this might attract further stakeholders to want to invest in artificial intelligence, and then we can find kind of new complex problems that we can develop an AI for. So I think there's like that immediate effect of the way it's existing, but by looking at it within an ill-defined problem, making sense of it, you're also asking the consequences of how it's affecting the future and like who's involved. But I think it's understanding that the ill-defined complex problem is multidimensional, that certain parts and jobs have different perspectives need to be asked on that question to find possible AI that's part.
I really like that thinking across time, because something like this is sort of meant to take on a life of its own sorts. Where do you think the indicators would come that you need to lean back in, course correct, get involved, because you can't get it all at the beginning, right? So
right.
As it has time to be in the wild or whatever is happening,
yeah.
What signals do you look for to get back involved, course correct, or learn from what's going on?
Well, I think it's like this idea of coevolution with the user. The question was asked of like, if it was like a menu, is there like vegan signs on the menu? Is there a way of observing? But I think that the dialogue, once it's out there, there has to be a way of kind of signaling back, having users involved. Like you could get kind of futuristic and say that there's live signals coming back and that you can always correct.
Let me give you a specific example, like how like here in your piece about shoes, right? It talked about flexibility. So these shoes give you a lot of flexibility. It could be physically, the shoe is flexible, or you could wear them to a dinner party or go running. So that's something that people might start to perceive that the machine is not understanding the difference between those two things. So like, how that back to you?
Right. Well, like in a recent system that we created, we're giving it to some industry users. We're like testing with them, and they're going to tell us if it's going to be effective for them or not, or so that will inform. And then we can tune the model, scrap the model, and create a new model completely. What is it that the users want? But it's this idea of involvement of the user early on, who's actually
with you there as a coach of sorts.
As a coach, yeah. I think something that I believe is like the changing role of design is the designer as a curator for auditing these systems. Not so much being able to integrate different set stakeholders within the problem, being able to conduct it so that we can go back and co-evolve with the people that are using it. The thing with AI that that I think is necessary is that it's not a product. It doesn't end once it's in the hands of the user, but it's a service. There's this give and take, and there's constant feedback, and this has to continuously happen. I say service, but it's co-evolving system. I think that has to be necessarily be integrated, so that it, like you said, doesn't run wild and just keep updating randomly and get worse and worse.
Also, so I'm a UX designer and industrial designer, and I'm learning data analytics. So I'm actively working on machine learning projects. So I think one of the challenges that I face as a designer on these projects is I don't really know at which stage can UX intervene. Like the process right now that is set up for machine learning does not have a stage for design. I think if designers want to be relevant in the process, they need to think about a stage. Like for example, in industrial design, when you design a product, you know where the UX comes into, like the interaction design. It could be with the form or it could be with the research. But in the machine learning part, I feel that is not there, and probably that is what is causing challenges for designers to fit in.
Yeah. So my master's degree was in user experience psychology, and that's like on this. And you saw here the ontology that we created, and this involved designers with the natural language processing to annotate language and build ground up. So this was a level of understanding the user and their language use and what type of categories they're using, so that this informed the model that we create.
But do you think we can standardize this for all the AI projects? Is there a way to standardize this, like interventions?
No, but what's nice about, what's interesting about this is that unique design knowledge, or the uniqueness or skills or expertise of the designer comes in and is able to understand the problem in that specific setting and needs to create a new model to address that problem. And so, knowing that you need to address what type of problem it is, establish a sense of semblance, then you create a model or a process until which certain outcomes can be made. But there's so many aspects and dimensions to each one that to standardize it, you could give criteria or recommendations to look out for. But this is what I'm saying, is that you establish the criteria.
Or also probably design could become an attribute for the AI to feel emotions. So, the one of the problems right now with AI is it does not have empathy. It does not have feelings. So maybe design could become that attribute where AI does the computation and gets the feeling algorithm and understand what kind of things it could say.
Yeah, I think I'm talking about the design as deliberation. So if you want to make an empathetic AI, this would be using design knowing and being able to.
ChatGPT was in theory of mind that 2 years old November, 9 years old January, and it's now probably 15 years old. The version 4 that comes out last week. And you could argue that theory of mind is not entirely the best way of measuring artificial intelligence age, like for human being, but it's probably the closest test that we can perform today. But even the 3, 9, now adolescent face of less than a year, we could all argue that by year end, maybe we're reaching the adult performance type of theory of mind, which at that point would be empathy, which is pretty close to the empathy of there is research that's done in places that shows that we, as human beings, do not trust the black box, especially when it comes to positive feedback. So with the AI, it's giving you a mortgage, you're not going to trust it. If it's refusing you the mortgage, you're going to like the decision for reasons that are currently so there is under research perception. It's I wonder.
So I had a similar question. Not actually take inputs via designs and also attach details to it. So I come across an article where the UX designers try to write requirements on paper and draw how the conference website will look like. And that is like an input to ChatGPT 4. And ChatGPT 4 could give you the whole JavaScript code, HTML code, and CSS code within minutes. So where do you think is AI taking us in terms of developers like UX one? Our main thought on AI was not understanding UX and emotions, right? But then a typical front-end developer or a UX designer, this would be their first criteria and their bread and butter. So where do you think that okay, this is where AI is going to stop, and then humans shouldn't appear, like a human mind created? Because in this case, the whole website was ready, including the CSS and JavaScript.
So my argument there, I'm sorry, I don't want to be right, is that one aspect that is really crucial here is the simplification that this thing brings about. I know adolescents today, high school students, in chat, not just write an essay, but write the software that catches the software that catches the user ChatGPT. The performance in software development that only a few months ago would be that of professional software engineer. Again, high school students still are drawings there. So when you have that ability to simplify things, we were talking before this in the case of the professional performance that I was just mentioning. The implication for us in society is very important because it's actually how. And that's the student things that and that is
also, I think recently ChatGPT told one of the users that I want to get into a physical form. That kind of created a fear.
I wonder if it might be interesting to think about like the word choreography as a thought experiment. So think of the word choreography in exchange for design. Because choreography, it has the same principles of design, but I have these specifically four-dimensional of arranging action in time and space. I've done it before, like I used to do it with like a book on architecture in the sense of by this Finnish writer, Johannes last night, read the book about architecture, replacing with architecture and dance, and the whole book makes sense. Still, and I was like, oh, this is interesting because like the two are completely different. They're manifesting completely different ways, but the principles structured and embedded by each are like there's a conversation, there's a dialogue. And you asked about time too, and I think thinking about like choreographic system in terms of what we're talking about here, because it involves action, I think just might be an interesting perspective to think about. I'm a dancer.
Yeah. No, I think, yeah, the idea of creating a choreography, designing a choreography, I still think that design deliberation is there at the beginning and dictating the way that we start to like understand it. But this is, I think, is what's important about integrating, different perspectives and people early on to understand, how will this system evolve over time, or how can we evolve further over time. This is like my argument today was just showing that like this is the case, that this does need to take place because it wasn't, or it hasn't been considered, or at least from the design perspective, that like these are indicated. I was thinking about it because designers were talking about AIs like after the fact. They're just thinking about like, well, they're going to come into my design process and I'm going to be affected by it. But it's like, no, like what if like me as a designer is early on, and I made the system and now it's behaving in the way that I designed, and now you are using it and you're getting feedback, inform me, and it goes and it becomes a informed algorithm.
It's also scoping too, like you're scoping on what's happening right now. And also,
Yeah.
I need to have a vision to think of where this could potentially be. And that's artistic. That's like creative as well as aesthetic. Yeah, like, that's ethically super important too.
Yeah.
It's just, I think the power.
Yeah, it goes to the idea of like the future thinking that you had brought up
Yeah.
earlier.
Yeah, it's futurism.
Yeah, but this is all implicated by what I'm trying to suggest just at the very beginning.
So I funded, so your line of thought, you showed the robotics, right?
Yeah.
And how do you feel about Boston robotics? It's dancing and developing the dexterity to jump.
It makes me very wary of my own ability. Makes me very wary of my own power. Yeah, I know quite a few one. I know few working. City's guy better, but all these people are like,
Did you feel scared?
yeah. I mean,
No, it's just a.
yeah. I mean, I tend to not be a person who love to hear anyway, but like it's like equal measure. Like it's curiosity, but you know, like with the ability. I mean, this is starting to evolve, right? Like you have ideas. It's things that literally reshaped our pattern entirely. And then we're having this conversation now, and you're like, oh, actually, I'm expressing this change in my own consciousness through the technology. It is artificial, but it's also not artificial. It's absolutely human. It's human.
But your practice is going to evolve. As
Yeah,
well.
it always does. Like you can't not, because it happens every time. Everything always happens.
Yeah.
Whether or not you want it.
It's all
Is that
it's a little bit
urgent?
I think the question really would be if, say, those Boston Dynamics robots were out roaming about, the question for me would be, what new ways are we gonna have to learn to move? Just like we call customer service, we have to talk differently to get the AI to like recognize what we're saying. I think that if those things were out and about and then there were certain systems that they were interacting with, we would be having to act more like them in order to be legible to the city.
You saw Cheetah, right? The Cheetah, the robot that's developed here in Boston.
Hmm.
The ones that walks with you, runs with you, something. From Boston Dynamics, we have the pet, the electronic pet that walks with you.
Very good.
What about the reception of, like, you're talking kind of about performance, right? In something where it's like, you have a robot that dance exactly like you. The audience perceive that as impressive as a person who's practiced and perfected.
I mean, I think that's awesome. Prepares their soul, like just because I mean, if this is like if we're using artistic creative to invent these things that we're talking about, intelligence, like that means it's human nature. Is there so the soul that comes from our experience as a species, which is like.
Well, I remember like the reception is like a live audience. Like, are you going to come see? Sorry, I know. Are you going to come see a computer simulate a cello performance, or have somebody sit in a chair and actually perform it? Well, I don't know that I would put something policy on the computer simulate. So,
I mean, think about that's the computer playing a cello with thing, but look at the context around it. So, like, is it interesting that space around? Is it in that ocean? On an island? Is it in your home high school? Like, the context is not. I think that's what these things too.
I mean, I think in the same sense of like, if I were to go see reform jazz, like the impressive part is that it's like a human, an imperfect person, and being able to think on their feet and create something unique. But obviously, an algorithm to generate that music will be able to create, freeform music derivatively from however many influences and much faster. That's not impressive. And going to see the ballet is like I think that it has to do with the imperfections and the, you know, seeing somebody be able to control their body despite such, you know, exertion. Yeah, but if something can do that 24/7, then that's not impressive. And, you know, you don't compare yourself to that robot in the same way. You compare yourself to this person does this every day, and I could replicate what they can do. It's like I'm never going to be able to do what the robot does. That's not. I can't compare myself to that. Like that's not. I can't aspire to be that robot, or I can't.
I mean, a robot is also like an outcome of an idea. So like at the point, I feel like artists in society have artists who give experts and people fully understand them, and they're like, let me show you. But okay, please listen to me. Like, you know, and then like, but the robot itself is like, that's an outcome. But I'm not sure if I'm fearful because I think it's gonna like be making. We will.
It seems like most of robotics become like humans. So actually in shape that picture that's what red bird that we are not trying to sample. From the sheet. So you can cross that and tension create like that, but yeah, I don't look like
It's exciting.
I'm sorry about to cut this conversation, but diet is always right.